Welcome, class, to the Intro to Java Programming. This is the first of 6 lessons on operators. Today we will review arithmetic and unary operators, including several code examples. Operators are used to perform operations on variables and values. Those operations can be in the form of expressions or conditions. Expressions can produce a value, assign a value, and possibly do nothing, like in the case of a void method call. In this lesson, we will focus on expressions producing a value in the form of a mathematical equation. A condition is used in a decision process to determine if the evaluation of two expressions are true or false. One example could be, is 3 greater than 2? This is a true condition. Let's go over the 5 common arithmetic operators. Addition uses the plus symbol and will add two values together. Subtraction uses the minus or hyphen symbol and will reduce the first value by the second value. Multiplication uses the asterisk symbol and will multiply two values. Division uses the slash symbol and will divide the first value by the second value. Modulus uses the percent symbol. Modulus is another way of saying give me the remainder of a division expression. If we divide 5 by 2, the result is 2 with a remainder of 1. 5 divided by 2 will equal 2. 5 modulus 2 will equal 1. Remember, modulus will divide the two numbers and return the remainder. Let's review some common uses for arithmetic operators. The first is with the use of numbers. Gross pay equals 40 times 10 will assign the variable gross pay with the result of the expression 40 times 10. Another use is with variables. Gross pay equals hours worked times pay rate will assign the variable gross pay with the result of the expression for variables hours worked times pay rate. We also have both variables and numbers. Gross pay equals hours worked times 10. Time for a Coach Joe challenge question. If we were to calculate the gross pay by taking hours worked multiplied by the current pay rate, which is 10, do you see a problem with using the expression gross pay equals hours worked times 10? Good observation. What if the pay rate changes in the future? Now you have to go into the code and change this value. Coach Joe rule number 9 states no magic numbers. Do not hard code numbers in the code. You should assign that value to a variable or a constant. The code will be easier to change and easier to read. Let's not forget that arithmetic operations can be performed using the results of method calls. The variable net pay is equal to the result of the method gross pay minus the result of the method get total taxes. Let's go to our basics project in IntelliJ, close any open class tabs. Let's create a new Java package called operators, and then let's create a new class called arithmetic test. Let's make some space, copy in this first test, import these classes. This first test will add two variables. Here we create and set two variables with a value. On this line we add two variables and store the result in a new variable. Let's run this test to verify the result is 30. And it passes. Here's a test that will subtract two variables. We create and set two variables with a value. On this line, we subtract one variable from another and store the results in a new variable. We can prove the result is 40 by running this test. And it passes. This test will multiply two values. Here we create and set two variables. On this line, we perform the multiplication and store the result in a new variable. And we can test the result for 42. Let's run this test. And it passes. This test will divide two values. We create and set two variables. This line will divide two numbers and store the result in a new variable. Let's run this test and verify 5 is the result. And it passes. This is a modulus test. It will determine the remainder of a division. We create and set two variables with a value. Here we divide value 1 by value 2. Remember, the percent is called the modulus. It will divide the value and return the remainder into a new variable. 42 divided by 5 is 8 with a remainder of 2. We will test to prove the remainder is 2. Let's run this test. And it passes. Correct. The variables do not need to be the same data type because we can take advantage of boxing and casting. Let's look at a couple examples of casting. This test will add an int and a double. Two variables are created, one double, one int. We have a compiler error on this line. Required int provided double. To correct this error, we should either cast this to an int or make this variable a double. If you remember from lesson 13 on casting, there is implicit typecasting and explicit typecasting. Implicit typecasting is done automatically when you convert a smaller data type to a larger data type. Explicit typecasting is converting a larger data type to a smaller data type and requires the developer to explicitly cast that to a smaller data type. Let's replace this line with a double variable. Now let's run the test. And it passes. Here's another test that adds a long and a float. The line commented has a compiler error. On this line, we'll do explicit typecasting. We will take the result of this expression, cast it to a long, and store the result in this variable. Let's run this test. And it passes. For the next three tests, I've hard-coded numbers instead of variables to make the examples easier to read. Next, we'll cover some basic order of operation tests. For starters, just remember that expressions inside parentheses are processed first, multiplication and division happen before addition and subtraction. This test shows how the expression is calculated with order of operation. Here we create and set a variable. Multiplication happens first, so 3 times 5 is 15. Addition happens next, so 4 plus 15 is now 19. Let's run this test. And it passes. This test shows order of operation with parentheses. Here we create and set a variable similar to the last test. This time the expression in the parentheses is calculated first. 4 plus 3 is 7. Then 7 is multiplied by 5 to be 35. Let's run this test to prove 35 is the result. It passes. And with this test we have nested parentheses. We set this variable with an expression. The inner parentheses are calculated first. This result becomes 40, and this result becomes 7. Then this parenthesis is calculated with the result of 28. And finally we are left with 40 minus 28, which is 12. Let's run this test. It passes. The order of operations in Java can be complex. You may need to do a search for Java order of operations to see a complete list. There is another arithmetic operator called unary operator. Unary operators are the types that only need one operand to perform common operations like increment, decrement, and negation. Plus plus is how you increment a variable by 1. Minus minus is how you decrement a variable by 1. Minus is how you change the sign of a variable. And exclamation mark is how you change the condition of a Boolean result or value. In the Project tab, let's add a new class inside of operators and let's call it Unary test. Let's make some space, copy in these first two tests, import in these classes. This test will show an addition with a unary prefix. Notice the initial value is 42. The test is expecting a value of 43. With the unary plus plus before the variable, the value is first incremented by 1. Let's run this test. And it passes. Value under test was incremented first, then tested in the assert statement. This test shows the same for subtraction with a unary prefix. Again, with the minus minus before the variable, the value returned is first decremented by 1. Let's run this test. It passes. Here are two more tests that show unary postfix. In the first test, we set a value to 42. The first assert will prove the value is still 42. It is important to note, with the plus plus after the variable, the current value is returned for the expression, then the variable is incremented. 42 will be the value for the first assert. The next assert will test to verify it is now 43. Let's run this test. And it passes. Here's the same test for subtraction with a unary postfix. And let's run this test. It passes. This test will show negation. We set a value to a positive number. On this line, we set the value under test variable equal to the negative value of value 1. The result should be negative 100. Let's run this test. It passes. This test will show how negation will turn a negative number into a positive number. Let's run this test. And it passes. In this test, we will use the unary not operator. The exclamation mark is often said as not. Here we are looking for not true, which should be false. Let's run this test to verify it passes. It does. Here's a summary of all the tests we wrote for the arithmetic operators. Here's a summary of all the tests we wrote for the unary operators. You should now have an understanding of arithmetic operators like addition, subtraction, multiplication, division, and modulus, or the division remainder. We touched upon expressions that use order of operations when producing a result. By using unary operators, we can easily increment, decrement, and negate variable expressions. The exclamation mark, or not unary operator, was our first look into a conditional process. Your optional homework assignment is to write a unit test with a modulus expression. Write another unit test that uses a postfix unary operator to increment a variable. In the next lesson, we'll discuss assignment operators. Remember, future senior developers, make it work, prove it works, then make it better. Ready? Break!